High availability refers to the design and configuration of a storage system in a way that it can experience component or software failures and continue to provide access to data. Much like a building requires a solid foundation in order to remain standing, an ONTAP cluster relies on high available pairs in order to continue serving data even during a component failure. ONTAP-based systems use a spectrum of hardware and software features to protect against failures from the individual storage system components to loss of network connections to an entire geographical region due to a disaster. The smallest component of an ONTAP cluster is the node, which is a single storage system that runs ONTAP software. An AFF or FAS node consists of storage and network ports. Depending on the model, the node might also have expansion slots for adding storage and network expansion cards. The node also has non-volatile RAM or memory for storing write data until the data is written to the drives. Data is stored on internal drives, external drives, or a combination of both. After physically racking the storage system hardware into a cabinet and setting the shelf IDs, your next step is to create the HA pairs. If the systems share a chassis, then the HA interconnect is already established via the backplane. Standalone systems require connecting two cables between the storage controllers. The cable type and ports used for the HA interconnect varies by platform and model, so consult Hardware Universe. High availability is most often used in reference to the multipath cabling of two storage nodes to provide failover protection when one node experiences a failure that brings the entire node offline. Multipath cabling is a requirement for all installations. This cabling method uses two paths from each controller to each drive and brings several advantages. Faulty cables can be replaced without requiring downtime. Firmware upgrades often offline the upgraded component. Having a connection to a redundant component allows the upgrades to be non-disruptive. If the environment needs to convert to optical cables, the changeout can occur while the system is running. Both storage nodes in a high availability pair must nearly be mirror images of the other. For example, if node A connects to a network that node B cannot access, then when node B has to take over the functionality of node A, the end users reliant on that network connection will be unable to access the storage system. A high availability or HA pair consists of two nodes that are connected through an internal interconnect when they are in the same chassis. They are connected through an HA interconnect when the storage controllers in the HA pair are in separate chassis. Cluster nodes are configured in HA pairs for fault tolerance and non-disruptive operations. Each node in an HA pair requires an HA interconnect between the controllers and connections to both its own disk shelves and its partner node shelves. The nodes also need to be connected to a cluster interconnect, even if the cluster is composed of only one HA pair. In an HA pair, when a node fails or is taken down for maintenance, the surviving node takes control of the partner's drives and continues to serve data. For multipath HA support, redundant primary and secondary connections are also required. For simplicity, these connections are not shown on the slide. The nodes are referred to as A and B due to the labels and icons on the chassis when both nodes share the same chassis. You will also see the A and B designation used for shelf controller modules in drive shelves. During normal operations, both nodes communicate their state to each other. The high availability cabling also transfers a heartbeat signal between the nodes. The surviving partner has two identities, with each identity able to access appropriate volumes and networks only. You can access the failed node using ONTAP commands. Takeover is the process in which a node takes over the storage of its partner. Giveback is the process in which that storage is returned to the partner. Both processes can be initiated manually or configured for automatic initiation. When a takeover occurs, the functioning partner node takes over the functions and disk drives of the failed node by creating an emulated storage system that assumes the identity of the failed node, accesses the failed node's disks, and serves its data to clients. The partner node maintains its own identity and its own primary functions, but also handles the added functionality of the failed node through the emulated node. After a partner node is repaired and operating normally, you can use the giveback command to return operations to the partner. When the failed node is functioning again, the following events can occur. You initiate a giveback command that terminates the emulated node on the partner. The failed node resumes normal operation, serving its own data. The high availability configuration resumes normal operation, with each node ready to take over for its partner if the partner fails. High availability ensures that data is still accessible even when the storage controller managing the data suffers a failure that takes the storage controller offline.